Khadija, can you hear me? Might be. All right. Speak over. Okay, we are ready to start the topic light today. All right, we have just concluded with the waves and sound, and now we are starting the second type of waves, the transverse wave, which is actually the light. Okay, and that light section, we have three portions. One is reflection of light. Then we have refraction. And lenses. So today we are going to do the reflection part of this entire topic. All right, and in that reflection, we will just deal with plane mirrors. We are going to look at the different aspects of reflection, plane mirror, ray diagram, and the nature of the image formed by the mirror. Okay, that comes in this reflection, including the two laws also. Then we will move on to refraction. Refraction is when ray moves from one medium to another and it bends. So we are going to discuss that, laws of refraction, critical angle, all right, and stuff like that. In lenses, we are going to look at the concave and convex lens, properties of these lenses, ray diagrams, images formed by these lenses, defects of human eye and its grammatics. All right, so this is the entire topic of light. So we are going to start it today. The good thing is it has nothing to do with the previous chapters or the current chapters. It is just an entire topic in its own. Okay, so right from reflection till lenses, it is not integrated with other topics like kinematics, energy dynamics, heat, etc. Yes, a bit of it later on is related to waves, just one formula that I'm going to explain to you. All right, so we're going to start with reflection. Instead of giving you the details of the other two topics, it's better to start with it. So when we say reflection of light, what is the first thing which comes to your mind? Anything else? The first impression. Johar. वापस आना. People online. Varsha, Made, Khadija, Hadi.
Sir, bounce.
Bounce. Bounce back कर लो. All right. Any other opinion or response? The first impression which comes to your mind when we say reflection of light. These all are related to reflection. Although it is the same reflection, but means coming back, bounces back. Good. Now, we have one or two things which you need to understand before we go into the details. This is, let's suppose, a bulb. Bulb. Nowadays we have LED bulbs or other ones. They just give light. These are the sources of light. One of the source of light. It emits, gives out light. If I just place a shiny surface in front of it, a mirror or a shiny metal piece, it is going to do something to the incoming rays. Rays which are incident on it what will happen to them? You think they will enter into it? No. They are going to bounce back. Bounce back. This bouncing back of the light from a shiny surface is called reflection of. What do we require for that? We need to have a source which provides the light and a reflector which reflects, usually a shining surface. Shiny surface, when we say that, here we are going to use mirrors instead of shining surface. Mirror. I'm sure you people might have played with the mirrors, you might have used them to reflect light and these people sometimes. Okay. But these mirrors, we have a variety of mirrors. There are like funny mirrors in which the deformed shapes or images they are formed. There are certain mirrors which gives you the close-up of your face. There are certain mirrors which gives the entire view. Okay. So we have curved mirrors. Some of them they are used at the dead ends to see the traffic on the other side. If you just go to the Murray or to that mountainous range, you will find that place at the sidewise so that you can see the traffic which might come from the other dead end or the other side. They are curved mirrors. The same way while you are doing your makeup, we have. So these are like concave and convex mirrors. But fortunately, we have to just study or consider plane mirrors. We are not looking at these curved mirrors. We'll just talk about plane mirror. This plane mirror we denote the mirror like this: a straight line with this. A straight line with one face with small these dots or short lines. So this is the incoming ray. Now, this side represents the back of the mirror. You might have seen that the mirror, when we just paint a glass with a silver polish, it turns into a mirror. But if we just look at the back of the mirror, we can't see that silver coating. Rather, we will see a gray or orange painted surface. Why it is so? Back of the mirror. Back of the mirror. Let's suppose I am just looking my face into it, and the back of this mirror is painted with gray paint or with orange, not with the silver. But from this side, I can see a silver polished surface inside it. Actually, we polish the mirrors with silver, and to protect that silver layer, we place another enamel on it another paint on it. Okay, to just protect that surface. All right. So it is going to reflect this incoming ray. This incoming ray is called incident ray. Incident ray. What do you expect? What will happen? It will bounce back like this, like this, not like this. A, B, or C? Which ray? Some people are saying C. G. Hadi, Khadija, Madir, Basha. A, B, or C?
Sir, C.
Okay, one more vote for that. Anybody for A or B?
C.
C, all right. Hadi and Ganesh, both of them, they are saying C. I'm not sure whether it is A, C, or B. Okay, let's consider another example. Let's suppose we got a mirror on a shiny polished surface. This is the shiny polished surface. And the incident ray is what do you expect? Will it reflect in this direction, this, and this? A, B, or C? D. Yeah, this is case A. Let me make it a little easier for you. Case 1, and this is case 2. This is a plane mirror, and this is a curved surface, uneven surface, shiny surface. So, इसमें you are very sure that it is going to be C. What about here? Johar.
Sir, B.
Right. Some people think B, some A. You are what? C. Why it is so? Why can't we say that in the same way we will have B? Okay. Can we have B? For example, can we have all right? Okay. So the point is, if the light it bounces back with the same angle as it is incident on any surface. In this case, this surface is not equal. So if we get the plane of this surface over here, then we need to make a normal. What is normal? In mathematics, you might have read normal. (90°) angle or a perpendicular line. Okay, so we have to draw a perpendicular over here, and that perpendicular is this black line. All right. So the two angles, they are equal always. Just give me a little liberty that I have just drawn it with my free hand, so you can see that these two angles they might not appear equal, but they should be. All right. In this case, when we make a perpendicular over here on this side, it was first of all very difficult. Secondly, these two angles, angle of incidence, angle of reflection should be the same. So it was difficult to determine in which direction we are going to have it. Now let's suppose we have more rays here, which are parallel. So all of them, they will be reflected uniformly. So a uniform pattern is formed here, and in this case, let's suppose we have parallel rays of light incident on this surface. Will you expect all of them they will show this type of pattern on that side? No. Depending on this point of incidence, they are going to reflect that in different angles. Okay? So this is the case. When we have a regular reflection, we'll have a sharp image, proper image. And this type of reflection is called regular. And this type of reflection, irregular or diffused. Diffused reflection. Here we get a sharp image, here we get a blur or probably no image. Okay, so we have two types of reflections, regular and irregular or diffused reflection. That all depends upon the surface which is reflecting the light. If the surface is smooth, shiny, it is going to produce regular. If it is irregular, then it is going to produce diffused. I'm sure you got an idea about this reflection. Any questions? All right, let's move on. So, this was the surface. Now, I just need to give you a little idea about the objects as well. We have three different types of objects: transparent, opaque, and translucent. What are transparent objects? Transparent surfaces are the surfaces through which light can pass. Pass through, yeah. जैसे glass है, ठीक है? या transparent plastic है, या ये जैसे wall clock का cover, right? They all are transparent. Light can easily pass through them, and you can see the objects on the other side clearly. Opaque are the objects to which light cannot pass. Wood or this thing, duster or stuff like that. Translucent. What are translucent? That can be source as a verb only. What is translucent? See, can anyone online student can tell us what type of objects which are translucent, how do they behave with the light?
Sir, where some light can pass through.
Thank you.
Like not all.
Excellent. Where some light can pass. Okay, not all. And they form a blur energy. We have like frosted glass for the windows. so you cannot see through them, but still you can figure out that something is behind the glass. All right. So if some light can pass through it, not all of it, so call it a translucent object. Okay. These translucent objects usually make this diffuse type of images, distorted images. You cannot see them clearly, but you can say that something is there. Okay. So we have transparent objects through which light can easily pass, opaque, no light can pass, translucent, some light can pass through them. Okay? If you want to make notes or write statements for yourself, please do that. Coming back to the plane mirror.
Sir,
G. Now, which side of this mirror is the front, the back? A or B? Which is the front side of this mirror? A? Sure? Yes. These small tiny lines over there, they indicate that it is the back. Okay? So this is the symbol for mirror. Now, let's suppose we have an incident ray. Incoming ray is called incident ray. ठीक है बेटा? This point at which this ray is meeting the mirror is called point of incidence. Point कितना बड़ा होता है? How big is the point? This much? This much? Or even smaller than this one? Yeah. Even the smaller than the tip of the needle. That is the point. And how big is the ray? One single ray. How thick it is? This much? Very small. Just a ray, which is just producing a point. So you can imagine how small this thing is. So I always ask my students to draw all this with a very sharp pencil. Sometimes students they make a broken, a curve, ray. Ray always traveling straight lines, sharp, straight line. Okay? That will represent a proper ray. What is the plural of ray? If we have a bunch of rays together traveling in the same direction, what do we call them? Rays. Okay, rays. Anybody else?
sir, सर थोड़ा सा ये गैप देख सकते हैं मेरी लैग कर रही थी तो
I cannot hold the class for you, beta. अभी कोई ऐसे ही चलेगा. Please join us on time. जी हादी, plural of ray.
Rays.
Rays. Okay. Beam. Thank you, Arham. Beam. Sometimes you say car beam. Beam is actually the plural of rays, right? Okay, ji. Incident ray. This is the point of incidence. By the way, Mahmood, you haven't missed much. Simply transparent, opaque और translucent की बात हुई है और अभी हमने ये start किया. Alright, this point is the point of incidence. At this point, we have to make a 90-degree line, 90 degree or normal on this surface, on this plane. Okay? I'm just doing it with the blue. Okay, red symbol. Is it 90 degree with this mirror? Appears, seems. Alright. Now, all that measurement of angles is done with reference to normal. I'm just writing N here, which stands for normal. This angle is called angle of, yes, and it is denoted by I. What do you expect? Where we should have this reflected ray? Here, here, A, B, or C. So, come on. Which one of them is the reflected ray? A, B, or C? All right, one vote for A. Another vote for A. What about B or C?
A, sir.
All right. Why you said A? Because angle of incidence is equal to angle of reflection. Shabash. So these two angles, they must be same. So this is angle of from here we can conclude that angle of incidence must be equal to angle of reflection for a plane mirror, right? This is our first law of reflection. First law of reflection. समझ आ रहा है? कोई क्वेश्चन यहाँ पर? Okay. Just tell me, are you familiar with the word plane? Mathematics में plane क्या होता है? Is it a 3D or 2D?
3D.
3D, okay? 3D, 2D. Anybody else? 2D. When we say 3D or 2D, we are taking the reference of the axis. It is 2D is X and Y axis. SIA. And 3D is X, Y, Z axis. All right. This image of this duster over here. Is it 2D or 3D? 2D.
2D.
And now I've tried to make the depth as well. So this is now turning into 3D. Okay? Now this circle and a sphere. Sphere is 3D and this circle is 2D. Alright? What about this whiteboard? If I just consider its front face. This whiteboard front face only. 2D? Alright. Good. Now, just tell me how many faces this duster has. 6 or 8 or 10? 6. Okay, let's see. Let's count them. Front 1, back 2, up 3, 4, 5, and 6 faces. If I just consider one face that is two-dimensional, that face is called plane. Okay? In mathematics, this face is called plane. The paper from your copy or book is a plane. Okay? It has almost negligible thickness. So if we just consider the face of that paper, we call it a plane. What I'm trying to explain to you? Plane समझ में आ रहा है? अगर plane समझ में आ गया तो गौर से सुनना. Incident ray, reflected ray, and the normal at the point of incidence all lie on the same plane. Is it true for it or not? नहीं समझ आया. मानूर समझ में आया ये? Incident ray, reflected ray, normal at the point of incidence, all three lie on the same plane. देखो अगर इंसिडेंट रे इस तरह से आ रही है और इधर आने की बजाय वो आपकी तरफ आना शुरू हो जाती है इधर, तो ये सेम प्लेन होता, प्लेन चेंज हो जाती. ठीक है, तो ये ऐसे आ रहा है और इसी प्लेन में ऑन द फेस ऑफ दिस व्हाइट बोर्ड हियर. सो दिस इज द सेकंड लॉ ऑफ रिफ्लेक्शन. Law is normal at the point of all lie on the same plane. Shabash. This is second. तो मुश्किल था फर्स्ट लॉ और सेकंड लॉ, बस इनको अच्छी तरह से आपने याद रखना. ठीक है, दिस इज रादर मोर इंपॉर्टेंट, ये आगे यूज भी होगा. ऑलराइट, ओके, कुछ नोट करना है तो बड़ा जल्दी से कर लो. No laws, just two laws, first and second. That's it. खत्म हो गया laws. मिरर में इमेज कैसी बनती है? ओके, इनको एक से नाम विजुअल और अपराइट. चलें, पहले हम सब अपना अपना नाम लिखते हैं. लेट्स सपोज असर. कैसे अपीयर होएगा ये मिरर के अंदर? चलो सब अपने अपने नाम लिखो एंड मेक अ लाइन इन फ्रंट ऑफ इट, और फिर जो मिरर में अपीयर होएगा वैसा उसके अल्फाबेट्स बनाओ, अपना अपना नाम. You have done that? अपना अपना नाम? All right. असद एक बच्चा हमारी क्लास उसने इन तीन तरह से अपने नाम को लिखा. Which one of them you think is correct? Asad will appear in the mirror 1 like this, 2 like this, 3 like this. Think about it. Think about it.
Sir, like the second one.
Okay, second one more, another more. Johar, anybody else? Second. Farhambi, honestly, second.
Sir, I think second one.
One would be second. कोई anybody for 1 or 3? कोई भी नहीं है. All right. क्यों? चलो मैं 1 and 2 मिटा भी देता हूँ. Why you? I mean, this is right, correct. Why you think so? इसको थोड़ा सा हम ऊपर भी कर ताकि इसके बिल्कुल सामने आए. Right?
Starting laterally inverted.
All right. Okay. Very good. Excellent. Let's suppose this is the candle. And this is mirror. Is it right or wrong? Is it right or wrong? One vote right, 3 vote for wrong. बाकी लोगों का क्या ख्याल है? गलत. Okay. जो right कह रहे हैं वो तो ठीक. जो wrong कह रहे हैं, why do you think it is wrong? Size. चलो size आ गया. Okay. Arham thinks that this distance of the object from the mirror and the distance between the image and the mirror is not same. This is not equal to this one. That's why it is wrong. This is wrong. Right? It means the object, the image should be as far behind the mirror as the object is in front of it. So that both these distances should be the same. Excellent. The other, it should be laterally inverted. You see, this D is not the reflection of this D. It must be like this D. This distance and this distance should be equal. Okay? So we need to make D like this distance and this distance should be same. All right? Now, we have just used two things here. Laterally inverted and same distance. Right? What is laterally inverted? What is laterally inverted? Only the laterals they are inverted. Sides they are inverted. It is not upside down. Remember, when you see yourself in a plane mirror, you see yourself upright. ऐसे ही होता है ना सुबह when you are brushing your hair, looking at the mirror, you appear like as you are. But your right side appears the left. When you move your right hand, the same side hand, it extends towards you. So that is laterally inverted. Instead of that hand, this side hand it comes in front of you. So this is lateral inverted. You are upright and inverted. Okay? So it's the same case here. If I just draw like B, so it will appear upright but in the inverted form as it appears. Understand this lateral inversion? What type of inversion is this? Let's suppose A is drawn here. Instead of this, if I just make it like this, what do we call this A? Inverted, shabash. This is inverted. Do we have any of the letters which if they appear inverted in the middle? No. No. They are always, what is the opposite of inverted? They are upright. Inverted versus upright. Okay? So all these laterally inverted, they are upright. They appear upright in the mirror. Okay. So these are actually the properties of image formed in the mirror. Yeah.